Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the last video we have seen a few questions which were very easy to design as a DFA. Let's see few more questions on that. The question over here is to construct a deterministic finite automata to accept the strings of even length on a given input alphabet 0 and 1. Let's see. We start with the initial state Q0. We want even length string. Let's say first input alphabet is 0 or a 1. Then we reach at Q1. Now the length is odd. On applying the input alphabet 0 or 1, it will have a transition from Q0 to Q1. So Q1 is the state which remembers the odd length. So definitely Q0 was the state which was remembering the even. So we'll go back to Q0 on an input alphabet 0 or 1. Which one should be the final state? Q0 or Q1? We know that all the length having even number of symbols, let's say 0 symbols, let's say 2 symbols, 0 and a 1, 1 or a 1, you will see always the even string ends at Q0 and odd string ends at Q1, and we want even length string as to be the final, so Q0 is the final state. So this is an example in which the initial state is as well as a final state. Let's see the mathematical definition. So let's name this to be machine M5, Q, sigma, delta, Q0 and F. What is Q? The set of states. So Q0 and Q1 are the set of state. Sigma is the input alphabet set, 0 and 1. Delta, let's try to draw delta using a table. So there are two states, Q0 and Q1. Initial state is Q0, which is also a final state, and the input alphabet set is 0 and 1. On 0, Q0 have a transition to Q1. Similarly on 1, it has a transition to Q1. Q1 has a transition on Q0 on both symbols. So this is our delta. We have seen Q, we have seen sigma, we have seen delta. What is Q0? It is the initial state. Final state is Q0 here. So with this, we have done with the definition of the DFA. One more DFA we are designing over here is going to accept the strings of length which are divisible by 3. Divisible by 3 means it will accept strings of length, let's say 0, 3, 6, 9, etc. So one thing you have to keep in mind is that we are trying to remember the number of input symbols. Whenever it is a multiple of 3, we will have to transit to a final state. Whenever it is not a multiple of 3, we have to transit to a non-final state. Let's start with again the initial state Q0. On the first input alphabet 0 or a 1, it will have a transition to, let's say, Q1. Now the length is 1. One more 0 or a 1, it will have a transition to Q2. Length is 2. Now, if one more input symbol is coming, 0 or a 1, then it will have a length 3, which is a multiple of 3. Similarly, 0 was a multiple of 3. So if 0 was considered to be multiple of 3, this has to be a final state. And on the next input alphabet, 0 or a 1, it should come back here. Now you see, this will accept all input alphabet set having a length of 3. Let's say the input string is given 0, 0, 0. 0 will have a transition from Q0 to Q1. Next 0 will have a transition from Q1 to Q2. Next 0 will have a transition to Q2 to Q0. So 0, 0, 0 is accepted. Let's say 1, 1. 1, 1, if you run, Q0 will have a transition to Q1. Next one will have a transition to Q2, and Q2 is non-final, so 1, 1 is rejected. So this is doing the exact job which is expected to be done. That is, it is accepting all strings of length divisible by 3. It is rejecting all strings whose length is not divisible by 3. Let's see the mathematical definition. So let's number this machine M6. Again we have the quintuple Q, sigma, delta, Q0 and F. What is Q? Set of states. The set of states over here are Q0, Q1 and Q2. Sigma is similar, 0 and 1. Delta, let's draw the transition state table. Q0, Q1, Q2. Q0 is the initial state, which is apparently the final state also. On input alphabet 0 and 1, Q0 has a transition to Q1, Q1 has a transition to Q2, Q2 has a transition to Q3. Here we have seen Q, sigma, delta. Q0 is again the initial state, then the final state. The final state is also Q0. In the last example, what we saw was a string having length which is multiple of 3. Now let's see a more complicated one. If we have a modular division with 3, the remainder has to be 2. That kind of string, like for example, the length of 2 or the length of 7, which is divided with 3 will have a remainder 2. So we have to accept those strings which exactly has a length which is having modulus 2 with respect to 3 and reject all other strings. Initial state Q0 again, having a transition to Q1. Let's have one more transition to Q2. We have to accept exactly those strings which are having length which is modulus 2 with respect to 3. The smallest string accepted has a length 2, either 0, 0, 0, 1, 1, 0 or 1, 1. And then the next one will have plus 3 because it is modulus 3 with respect to modulus 2 with respect to 3. So this DFA look exactly like the previous one, but you see the final state is now that state which remembers modulus 2 rather than modulus 0, because modulus 0 was divisible and modulus 2 is the one which gives remainder 2. Here it is Q2. That is why the final state has to be Q2. Let's see the mathematical definition. M, which is Q, sigma, delta, Q0 and F. Q is the set of states. Here it is Q0, Q1 and Q2. Sigma is the input alphabet, 0 or a 1. Delta, the transition function, Q0, Q1, Q2. Out of them, Q0 is the initial state, Q2 is the final state. 0 or a 1 is the input alphabet. Q0 have a transition to Q1, Q1 have transition to Q2, and Q2 have transition to Q0 back. With this we have discussed Q, sigma, delta. Q0 as we saw is the initial state. We have represented that using an arrow coming from nowhere. And what is the final state? The final state is the state Q2. With this, we are done with few more examples of deterministic finite automata construction. In the next video, we will see few more complicated questions of DFA designing. Thank you for watching. Stay tuned to the Ekeeda channel and do subscribe to the channel. Thank you.